Okay, 6.2 is vector addition. Now, I just put a little example here on what vector addition really means, so we can visualize it. This is a cargo ship that's holding cargo. I know I'm such a good artist. And these are two tugboats tugging the cargo ships in two different directions. So when we add vectors, we use this vector and this vector. What adding vector means is which direction is this ship going to move? Well, it's going to depend on which way this ship is going and this ship, and how hard this one is pulling and how hard this one is pulling. So those are the two quantities for each vector. And adding these two is vector addition. So for instance, I'm going to redraw it over here. You might as well use blue. If I wanted to figure out these two vectors added, it's kind of this right here. Now, how do we visualize this? Well, we can consider this the parallelogram law for adding vectors, which means we can really just create a parallelogram here, and the diagonal of this parallelogram, is the addition of those two vectors. So for instance, if this is vector B and this is vector A, this middle piece is A plus B. And that's an arrow, by the way, of that vector. Okay, now, why is this super awesome? Well, if this is a parallelogram, it means that I can translate this B on this side and this A on this side. And why does that help me? Because if I know this angle that separates the two initial vectors, I know the law of parallelograms tells me that this angle is supplementary to this theta. This is C pattern, or you can think of it as opposite angles in a parallelogram. So if this is 60, I know this angle is 120. And if I know two sides of a non-right angle triangle and the angle in the middle, this is cosine law. So every time I'm finding A plus B, all I'm doing is using cosine law with the supplementary angle that separates the two vectors. It's that straightforward. Okay, I'm going to get into an example right now. And really, you can just imagine a triangle here. There's parallelogram law, but really what we're doing is we're creating a triangle. So you don't really have to imagine a parallelogram. If you do the triangle, it's half the work. So, example. Here is my two vectors. This is A, this is 60 degrees, and I can call this vector A. This could be B, this could be D, these are just directions, and 60 degrees. I want to find A plus B. If, and I'll tell you the values of A is 2, and B is 3. Okay, so what I want to do here is either create a triangle or parallelogram, okay, or imagine it. And I want to find this middle value right across here, which makes this angle 120 degrees, and this is B as well. Okay, again, the supplementary angle in a parallelogram, if this is 60, this is 180 minus 60, and now I have the angle that's between the two vectors that I'm interested in, okay, which is going to find this diagonal. So I'm going to set this up like cosine law. I want to find A plus B, which is this guy right here. And cosine law is, if I'm finding this side length, it's these two side lengths squared, A squared plus B squared, I can use magnitude, minus 2 times A times B, cos of 60, regular cosine law. Now I'm going to plug in the values. 2 squared, 3 squared, 2, 2, 3, brackets. I lied about the cos of 60, it's supposed to be cos of 120. Okay, and cos of 120 is negative 1 over 2. So I'm just going to replace the cos of 120 with negative 1 over 2. It's like cos of 60, just in the negative cast rule, you know, it's on the left side. Okay, anyways, I'm going to add these all up, and this is going to be 19, therefore root 19 is a plus b. Okay, because this is going to be the square, so root 19. Now, that's it. This is the value of a plus b. I can box this answer. I can say, therefore, a plus b is root 19, but it's all cosine law. So if you're rusty with cosine law, you don't know how to use your calculator in one step, or you don't understand this exact value, you really need to brush up your cosine law skills, because everything from now on is pretty much going to be cosine law. Okay, and I'm going to just show you subtracting vectors after on the next screen, and then we're pretty much done. Okay, so just the difference between vector addition and vector subtraction. So for instance, if I'm adding two vectors, before I even add them, I need to set up my vector. This right here is head to tail. The head of the first vector with the tail of the second vector. And this gives me my a plus b, that diagonal in that parallelogram. Subtracting, on the other hand, is actually tail to tail. So this is how I want to set it up. This is tail to tail. And this right here is my a minus b. So this is cosine law with this angle, whereas this one, first I have to find the supplementary angle, and then I use cosine law. So that's going to really be the biggest difference between vector addition and vector subtraction. It's just the angle you use, because obviously the two vectors that you're adding and subtracting, those numbers still have to be used. But that angle is going to be very important. Understanding how to draw these diagrams is going to be a struggle, but I hope this kind of makes a lot of sense, because it's not that difficult.